So in yesterday's lecture, we have discussed about the theories of acid and bases. Okay, all right. So basically, we have three theories that can be used to describe acid and bases. So first, we have Arrhenius, and then we have Bronsted-Lowry. Then we also have Lewis. Okay, all right. So make sure that you know the difference between these three theories. Okay. Now moving on, we have done this checkpoint yesterday. 3.2 strength of acid and bases. Okay, all right. So as you can see, we have a lot of learning objective for this subtopic. Okay, 1, 2, 3, 4, 5, 6, 7. So we have 7 learning objective for this subtopic alone. Okay, make sure that you cover them all. Right? Oh. Okay. Right. Moving on, the strength of an molecular structure and acid strength. Okay, we're going to start with acid. Normally, we will start with acid first. Okay, the acid strength, and then we have the base strength. The strength of an acid depends on how easily the proton or H plus is lost or removed from an HX bond. Okay, in the acid species. Okay, so earlier on we have the definition of acid. Now we will look into uh, the molecular of acid itself. Okay, all right. We know that acid normally it would contribute H plus. Okay, it has a apa nama tu hydrogen, okay, ataupun proton attached to the molecule. So the easier, how easily the proton is to be removed. Okay, the easier the proton, the easier it is to remove the proton, the stronger the acid is. Okay. So that's the basic of apa nama tu, the fundamental of acid strength lah. Okay, it is based on the strength of the bond. Okay, the strength of this HX bond. So this bond. So if it is easily broken, that means it will remove this H plus easily. That means the stronger the acid is. Lagi senang nak break this bond, lagi kuatlah acid tu. So oppositely, maksudnya conversely, the harder it is to break this bond, okay, the weaker the acid is. Okay, all right. So the bond polarity between H and the atom to which it is bonded. So it depends, okay, it also depends on the bond polarity between hydrogen and the atom to which it is bonded. Satu, it depends on the apa nama tu, kesenangan, how easily the proton to be removed, okay, and then the bond polarity. Okay, so these are the two factors that affect the strength of an acid. Okay, so we have 1, 2, 3, 4, 4 types of acids. Okay, we are going to cover all of them later on. So we have binary acid. The word bi stands for we have two species involved in the acid. Okay, so normally we will represent it as HX. For example, we have HCl, HBr. Okay, so these are the example of binary acid. And then we have polyprotic acid. Poly means banyak, protic means dissociation. Okay, acid means the substance consists of H. Okay, so polyprotic acid means acid that consists of more than one hydrogen. Okay, for example, we have H2SO4 and also H3PO4. And then oxo acid, the word oxo there, okay, maybe you are familiar with this already. We have learned this in topic 1 last time during our semester 1. Okay, we learn on how to name acid, right? How to name an acid is either binary acid ataupun oxo acid. Okay, all right. Oxo acid means the acid consists of oxygen. Okay, the acid consists of oxygen. For example, we have HNO3 and also HClO4. Okay, all right. Last but not least, we have organic acid. Organic, that means it consists of carbon and hydrogen. Okay, and then it has a hydrogen that can be removed in order to produce proton and finally become an acid. For example, we have this ethanoic acid. So this part is what we call organic, and this part is the carboxylic part. The H will be removed to produce proton. Okay, so these are the types of acid that you should know. Okay, let's start with binary acid. For a binary acid, as we go down the group in the periodic table, the size of X increases, makes the HX bond get longer and weaker, thus the strength of the acid increases. Okay, all right, what we want to know now, what we want to study is the strength of acid based on the type of acid that we have learned just now. Okay, kekuatan acid tu, dia setiap acid yang ni, this 4 acid, dia ada kekuatan dia ada perangai dia sendiri, dia ada nature dia sendiri. Okay, alright. So what could be the factor that affect the strength of each acid that we have here? For example, if we have binary acid, dia akan based on the trend of periodic table. Okay, as we go down the group, the periodic table, okay, as we go down the group, the size of X increases kan. Bila kita turun bawah, the size become larger due to increase in N, for example kan, increase in shell kan, so the size become larger. So the size of X increases, this makes the HX bond get longer and weaker, so they become far apart, dia jadi panjang dan lemah, thus the strength of the acid increase. Okay, ingat, lagi senang the bond to be broken, lagi senang dia nak remove the hydrogen, lagi kuat the acid is. Itu kekuatan dia, bukannya lagi kuat bond tu, lagi kuat bond tu, lagi kuat acid tu. No. Okay, ingat acid dia produce H plus kan? Betul tak? Dia normally acid will produce H plus. So lagi senang nak produce H plus, that means the stronger the acid become. Okay, alright, so based on this one, as we go down the group, the size become larger, so they get further apart from one another, dia jadi lagi jauh, and what happened to the bond? The bond become weaker, so it is easier to break the bond, and the H can be released as well, okay, and produce proton. Okay, alright, for example, here HF, okay, so group 17 lah. Group 17 is very famous for acids, okay, for binary acid. So as we go down the group, okay, the size become larger and therefore the bond become longer and weaker, and the strength of the acid also increases. So HI is stronger. Okay, HI is the strongest acid compared to HF. Okay, HF is the smallest kan, in terms of molecular punya structure, it is the smallest. So lagi kecil, maksudnya dia dekat, the bond become shorter. Shorter as in the attraction between the two atoms are stronger. Bila dia stronger, dia tak nak let go the hydrogen. So if you don't want to let go the hydrogen, how can you produce an acid? Okay. Alright, so that is going down the group. Kalau going across a period, the electronegativity. Okay, we're going to talk about electronegativity as we go across the period. Electronegativity increases, betul tak? okay, the HX bond polarity increases as well. The strength of the acid increase. Okay, all right, so binary acid also depends on electronegativity. So as we go across the period, the electronegativity increase, and at the same time, the strength of the acid also increase. Okay, for example, group 16 and group 17. Okay, all right, H2O dengan HF. H2O is less acidic than HF. In fact, H2O behave H2O has amphoteric characteristic, whereas HF behave more acidic compared to H2O. Okay, due to what? Due to increase in electronegativity. Okay, all right. Done. Guys, we are done with binary acid. Cancer. Okay, so these two are, make sure that you know how to describe binary acid. Okay, please remember that you have to describe in terms of going down the group and across the period. Okay, right. We have oxo acid. Okay, reaction of oxo acid with water involve breaking of an OH bond, this bond. Okay, all right. So the reason is it is called oxo acid because the hydrogen is attached to oxygen. Okay, the hydrogen that need to be removed, that will be removed later, is directly attached to the oxygen. So the strength of an oxo acid is determined by how the group of atoms attached to oxygen affects the polarity. Okay, the acid strength increases as the electronegativity of Y increases. Okay, all right, we know that oxygen, okay, look at the picture here, the diagram here. So we have HClO and HBrO. All right, we know that this hydrogen is the one that need to be removed later on. So this hydrogen is directly attached to O. Same goes for HClO and HBrO. Sama, the hydrogen is directly attached to O. But what contribute to the how easily for the bond, how easy for the bond to be broken, it depends on the group of atom that is attached to the oxygen. Dia bergantung kepada siapakah atom yang attached kepada oxygen. Okay, alright. Dia depend on the electronegativity of the atom. Okay, alright. It depends on the, for example, we have Cl dengan Br. Okay, alright. So which of these two has higher electronegativity? So the answer is Cl. Okay, going down the group, electronegativity decreases. Okay, going down the group, electronegativity decreases. So Cl is located above Br, therefore Cl is more electronegative than Br. Okay, therefore HClO is a stronger acid than HBrO because Cl is more electronegative than Br. Okay, so what actually happened is that Cl effectively withdraws. Withdraws means dia tarik. Okay, dia tarik the electron density from the OH bond, resulting the OH bond more polar as well as weaken the bond. Okay, alright. Mungkin what do you mean by withdraw? Okay, mungkin tak berapa nak nampak. Let me clear everything off first. Okay, alright. So Cl, okay, depends on the electronegativity of this atom. Okay, alright. So kenapa Cl being more electronegative, being more electronegative, has the ability, causing the acid to become stronger. Kenapa kehadiran orang-orang yang lebih electronegative menyebabkan the acid become stronger? Okay, right. This is because the more electronegative the atom is, it will withdraws the electron density. Remember, the bond yang dekat kawasan ni, ini bond. bond is made by electron. Dibuat daripada the electron sharing. So it withdraws, dia tarik electron density towards Cl, towards orang yang more electronegative ni. Okay, dia menarik, dia ada that ability because of dia punya electronegativity. Dia sangat electronegative sehingga dia boleh tarik other electron density, okay, which is quite far from this atom, but it has the ability to withdraw the electron density towards it. Okay, and what happens is that bila itu berlaku, this cause this bond, okay, between O dengan H ni to become more polar lah, sebab dia dah jadi, dia become, the other side become more electronegative and this side become more positive. Remember polarity when you have two poles kan, you ada dua dipole dekat situ. Lagi sangat berbeza dekat situ, lagi high tendency for the bond to be broken down. Okay, alright, so this is what happens. So the bond become more polar, and this also bila the electron density being withdrawn ataupun being pushed to the most electronegative atom, this also weaken the bond, melemahkan bond tersebut. Okay, dia melemahkan bond tersebut. So that's why the more electronegative atom has that ability to withdraw, dia menarik all the electrons density towards it. Okay, so HBr, yes, it is also electronegative, but not as electronegative compared to Cl. So memang electron density pun tertarik towards Br, but not as powerful as HClO. Okay, when you have not as powerful as Cl lah. Okay. Okay, that is in terms of the type of atom that is attached to the OH bond. Okay, that is attached to O lah, basically that is directly attached to O. Okay, alright. Another type of oxo acid adalah, bukan another type. If we were to compare, okay, we were to compare the oxo acid in terms of the number of oxygen present in the acid. For example, cuba tengok we have HClO, we have HClO2, HClO3 and HClO4. Basically, okay, dia punya electronegative atom dia tu sama, Cl, 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 Cl. It's just that now number of oxygen atom are different. The number of oxygen atom is now increases. So this also plays a role in terms of plays a role in determining the strength of an acid. So how do we identify which one is the strongest? Okay, which one is the weakest? Okay, yang ni kita kena consider something else lah. Okay, alright. This is what we call series of oxo acid. Okay, basically we have the same in terms of electronegative atom. Okay, the same atom attached to the oxygen. Okay, it's just that the number attached to the oxygen, which is this one, it's just that the number of oxygen surrounding that atom is now different. Okay, it's now varies. Okay, okay, that have same central atom. So that's the word sebenarnya, same central atom but different number of lone oxygen. The acid strength increases as lone oxygen increases. So lagi banyak oxygen atom present in acid. Okay, for oxo acid, we are talking about oxo acid. The stronger the acid become. Okay, for example, HClO4 is the strongest acid because there are 3 lone oxygen atom attached to central atom. Okay, alright. This will pull the electron density. Okay, bukan saya cakap push ke tadi. Saya patut kena guna pull. Tarik, withdraw ataupun pull. This will pull the electron density from central atom, which increases the central atom's ability to draw the electron density away from OH bond. Okay, alright, so what actually happened here, bila ada banyak oxygen surrounding the central atom, atau in this case surrounding the Cl, the oxygen tu, you know that oxygen is one of the most electronegative atom in the periodic table kan? Remember fluorine, oxygen and nitrogen. So these three are the most electronegative atom in the periodic table. Okay, ranking dia fluorine, oxygen and nitrogen. So when you have oxygen ataupun most electronegative atom surrounding an atom, atau in this case surrounding the chlorine, so what actually happen is that oxygen tu dia menarik, okay, dia pull the electron density from central atom. Okay, let's look at HClO4. Okay, we have 3 oxygen there. This is the oxygen yang attached kepada H lah. Okay, we have 3 oxygen surrounding the Cl. So, 3 oksigen ni ada kebolehan, maksudnya elektronegatif kan, dia kebolehan menarik the electron density from Cl. Okay, dia menarik electron density from Cl. And Cl pula, okay, disebabkan dia punya electron density has been pulled from itself, okay, dia pula menarik, okay, from this bond. Okay, so ini dia tarik ke arah dia lah, dia tarik ke O. Okay, the electron density of Cl is being pulled from it, okay, from Cl, ditarik oleh oksigen. So Cl sekarang ni dia sangat-sangat polar, okay, alright, and at the same time Cl is also pulling the electron density from this bond, from the O and H. So this will cause this OH bond to be very polar, and it also weaken the bond, and therefore finally the bond is easily broken. Okay, cerita dia dekat sini, dekat situ. So that is why HClO4 is the strongest compared to HClO3, HClO2 and HClO. The more lone oxygen result in more polar OH bond as well as weaken the bond. Okay, alright, next let's move on to polyprotic acid. So we are done with this one just now. Cancel. Okay, alright. Next is polyprotic acid. So the acid that has more than 1 hydrogen. Okay, that has more than 1 hydrogen in the molecule. So the acid strength of a polyprotic acid and it's an ion, which we can call it as conjugate base. Remember, apa tadi kita belajar Bronsted-Lowry last time? We have acid, dia punya pairing, okay, after the H has been removed, dia jadi conjugate base. Okay, alright, so acid, and once dia jadi an ion, it becomes conjugate base. Okay, so the acid strength of a polyprotic acid and its anion decreases with increasing negative charge. Okay, so the acid strength depends on the negative charge of the conjugate base. So the lower, is it decrease? The lower the negative charge, that means the stronger the acid become. Okay, decreases with and its ion conjugate base decreases with increasing negative charge. Ataupun kata lainnya, lagi tinggi negative charge untuk dia punya anion ataupun dia punya conjugate base dia, lagi weaker the acid is. Okay, decreases with increasing negative charge. Okay, if we were to compare between H3PO4, H2PO4 minus and HPO42 minus, we want to determine which of these. Inilah sebab dia ada more than 1 hydrogen. That is why it is called polyprotic acid. So, ini dia ada 3 steps. in order to remove the hydrogen, okay, to produce proton. Okay, H3PO4, it will dissociate into H2PO4 minus, and then this H2PO4 minus, okay, will dissociate into HPO42 minus, and this one will be dissociate further and producing PO43 minus. So dekat sini, how do we determine which of these three, okay, which of these acid is the strongest acid? Okay, alright, dia akan based on dia punya negative charge, okay, lagi rendah negative charge dia sebenarnya dia lagi kuat. Okay, the acid strength become stronger. So H3PO4 is a stronger acid than H2PO4 minus. Okay, H2PO4 minus is stronger than HPO42 minus. Okay, alright, so for polyprotic acid, you must base on the negative charge of the conjugate base. Yes, the negative charge of the conjugate base. As you can see, okay, H3PO4 yang paling power, dia paling kuat. Kenapa? It produce -1 conjugate anion. Dia punya conjugate anion dia punya tu adalah -1 sahaja. Okay, followed by H2PO4 minus. Kenapa? Because it produce -2 compared to HPO42 minus, sebab dia punya anion punya charge is the highest. Dia produce 3 minus ion bila dia dissociate. Okay? Alright. So this is polyprotic acid, guys. Okay? Alright, done with that. Moving on to carboxylic acid. Okay, do you have questions so far? Okay, ada soalan ke related to binary? Then we have Oxo acid. Then the last one just now we have polyprotic acid. Okay, before we coming to carboxylic acid. You have questions so far?
No, madam. So far, okay.
No, madam.
Right. Okay, baguslah Alhamdulillah. Okay. Standby. Okay. Okay, last but not least is carboxylic acid. Belum terlupa nak delete. Saja, lagi panjang. Lagi lama, lagi panjang. Sampai habis lepas ni. Okay. Last but not least is carboxylic acid. Okay, carboxylic acid, or can be written as this. This is like the general chemical formula for carboxylic acid. Okay, general chemical formula for carboxylic acid are relatively weak acid. Okay, in comparison to binary polyprotic and oxo acid just now, carboxylic acid is the weakest. Okay, it's the weakest sebenarnya. Kalau in general kita nak rank them, okay, carboxylic acid is the weakest acid. This is because the alkyl group, which is the R, okay, R is the part yang organic part tu. Okay, R is an electron donating. Remember oxygen tadi yang also acid tadi, apa maksud dia electron donating? Okay, just now kita ada oxygen tu kan? It is called electron withdrawing. Kemain kokolah. Electron withdrawing. Electron pulling group. Tapi dia tak cakap dalam term macam tu. Tapi sebenarnya oksigen yang banyak tadi kan. It is called electron withdrawing ataupun electron pulling group. Dia tarik the electron density toward itself. Sebab dia more electronegative. Betul tak? So dia tarik toward itself. But carboxylic acid on the other hand ataupun opposite to that, dia instead of dia tarik, dia push. Okay, donate, dia bagi the electron density dia tu towards the bond. Okay, towards the bond. So this is what we call positive inductive effect. Sebab donating kan, dia donate the electron density. And this in return will increase the electron density on the oxygen atom in the CO bond, okay, resulting the OH bond become less polar, thus strengthen the bond. Bila dia strengthen the bond, it is harder to break the bond between the hydrogen and the oxygen. Bila susah nak break the bond, that means susah nak jadi acid. Acid, kekuatan acid dimeasure based on kesenangan hydrogen to be removed. Lagi senang dia remove, lagi senang dia dissociate, lagi kuatlah acid tu. But this is opposite to carboxylic acid due to the R, the presence of R. Okay, because we have an electron donating group. So this will increase the electron density on the oxygen atom in the CO bond, resulting the OH bond become less polar, thus strengthen the bond. Luckily kita dah cover oxo acid tu kan. Oxo acid tu dia oxygen tu behave sebagai electron withdrawing ataupun electron pulling group. So dia tarik all the electron density from the bond. But this time dia bagi, push. Okay, they donate. So this makes proton loss. Okay, we want the proton to be easily removed. That is what we want. Okay, but this effect, okay, cause the proton to be to be more difficult to be removed. Okay, it is very difficult to remove the proton, which consequently reduces the dissociation or partially ionized in water. Boleh, tapi dia lebih payah lah compared to other acid just now. Okay, alright, so we have a note here, inductive effect. What is inductive effect? Is the shift in electron density from one atom to another through the sigma bond. The arrow showing the direction of the shift of the electronic charge as shown on the right. Okay, like I said just now, the electron density is being transferred from one group of atom to the bond. Okay, to the bond. So they transfer, inductive means they induce. Okay, they donate the electron density to the bond. So this causes the bond to become even stronger. Okay, right. Example of organic acid. So these are all organic acid. Okay, so this is what we call the R ataupun dia punya alkyl group. This is what alkyl group looks like. Okay, alright. So this is arrow dia, nampak tak, dia menolak ke arah oksigen dengan hidrogen tu. Kalau this is oxygen just now, oxo acid, dia tarik, dia pergi sana. Okay, but this is electron donating ataupun inductive effect. Okay, imagine if you have more ataupun bulky group of R ataupun alkyl group, so the inductive effect will be even larger. Okay, ni nampak ni. This is considered as bulky group. So everybody want to donate ataupun to give that inductive effect to this OH lah specifically. Okay, and this will cause the bond to become even stronger. Okay, and at the same time decrease the acidity. Okay, right, done. Okay, nak bagi patah balik 2 kali. Okay, over. Okay, alright. Done untuk acid. Okay, now moving on to base strength. Okay, so we have strong base and weak base. In fact, for acid just now pun kita ada strong acid, and even in binary acid we have strong acid. In combination of all acid we have strong acid and strong base. Strong acid and weak acid. Okay, it's just that base ni dia very straightforward. Okay, kita boleh simply separate them into strong base and weak base. Simple saja. Strong base, okay, atom coming from group 1 and group 2. As simple as that. Okay, metal oxide from group 1A and 2A. For example, sodium oxide, calcium oxide. And also metal hydroxide. We have metal oxide and metal hydroxide. Again, coming from 1A and 2A. Sodium hydroxide, calcium hydroxide. Okay, this is just example lah. Okay, kita ada magnesium hydroxide. What else? Apa ya? Potassium oxide kan, potassium hydroxide. Those basically elements come from group 1 and group 2. Okay, they are considered as strong base. On the other hand, weak base, okay, weak bases are compounds containing electron-rich species such as ammonia, okay, methylamine, and other amine group that contain lone pair. So weak base normally consists of nitrogen ataupun containing electron-rich species. Ni nitrogen kan dia ada electron pair. It has lone pair on it. Okay, so this is what we call electron-rich species. So molecules that have these electron-rich species, normally they would behave as weak base. So senang, kita nak identify senang. Kalau ada nitrogen, most likely it will be weak base. Weak base bukan weak acid weak base. A. Alright, so question, checkpoint 3, question 1, the strong and weak acid and bases can be simply predicted based on their molecular structure. Okay. Okay, classify each of the following compound as a strong acid, weak acid, and strong base or weak base. Justify your answer. Okay, alright guys. Maybe you can have like 2 minutes, okay, for you to complete this checkpoint. Okay, what? Checkpoint. All of them, okay, question 1. Okay, alright, so it's already 3:44 p.m. Just now kita start 3:42. Okay, alright, so let's discuss A, KOH. Is it strong acid, is it strong acid or weak acid or strong base or weak base? Guys.
Strong base. Strong.
Okay, it is.
Base.
Alright, it is a strong base. Okay, how about B?
Weak acid.
Weak acid.
Okay, weak acid. Yeah, kenapa dia weak acid? How do you know that this is weak acid?
From carboxylic acid.
Based on
The
what?
alkyl group.
Due to carboxylic acid just now?
Alkyl.
Okay, due to alkyl group. Ya betul, carboxylic acid. And then one more thing, it has alkyl group. Okay, make sure you are able to elaborate further lah you punya answer. Okay, alright. How about C? Is it strong acid, weak base, or strong base?
Strong acid.
Strong.
Strong acid.
Okay, alright. Okay, it is a strong acid. What type of acid is this, guys? What type of acid is this?
Oxo acid.
Oxo acid.
Okay, all right. So it is an oxo acid, and then the reason it is a strong acid is because of the presence of oxygen. Okay, the number of oxygen present in the acid lah. Okay, all right. D. How about D, guys? Is it weak acid, weak base, strong acid, strong base?
Weak base.
Okay, it is a weak base. Okay, the weak base because of the presence of nitrogen, which is the atom that is rich in electron. Right, so A, strong base, because K is one of the group from potassium lah. Potassium come from group 1A. Weak acid, B is weak acid. Okay, again, good. Carboxylic acid indicated by the COOH group. Okay, and the COO proton is the only ionizable proton in this compound. Okay, you jangan tengok dia ada banyak-banyak H kat situ. You ingat semua ni boleh produce hydrogen bukan. The one that contribute to the proton is this hydrogen only. Okay, alright. Strong acid HClO4 just now, okay, is an oxo acid in which the 3 lone oxygen atom attached to central atom, pulling the electron density from central atom, which increases the central atom ability to draw the electron density away from OH bond. This will make the OH bond become more polar and weak, thus easier to donate a proton. Okay, ni cerita dia lah tadi in detail. Okay, alright. So rasanya tahu ni cerita, tapi biasalah masalah student adalah to put it into sentence. It takes time lah sebab you baru belajar tadi kan. Okay, find a way so that you can describe why HClO4 is strong. With base. Okay, has a lone pair of electron on the nitrogen and it is an amine. Normally dia adalah amine, dia adalah weak base. Okay, alright. Arrange the following species in increasing order of acid strength. Okay, so this one will be your homework. This one will be discussed next week. Okay, maybe very quickly. Okay, we have like 2 minutes. Sekejap, saya nak tengok We have like 2 minutes before we end our session. Okay, right. Just now kita identify the strength of an acid based on the molecular of the acid itself. Okay, based on the molecular of the acid itself. Alright, so this time around, kita nak start ke arah calculation later on. Kita dah nak start ke arah itu. So before we could calculate, we should identify the strength of an acid ataupun base. Like I said, and like what we have discussed earlier, the strength of an acid or base depends on the degree of dissociation of the acid or base in water. Normally, they would show their characteristic when they are dissolved in water. Okay, and the strength of an acid sebenarnya, despite dia punya molecular structure tu, dia contribute kepada dia punya strength. Tapi, at the end of the day, it depends on the degree of dissociation of the acid and base in water. Dia bergantung pada degree of dissociation of the acid in water. Okay, tapi molekular punya structure tu, yes, dia main peranan. Okay, dia contribute to the degree of dissociation of the acid or base in water. Okay, alright, so strong acid. Why do we define acid as a strong acid ataupun base as strong base? Okay, it is because it dissociates completely, guys. The word completely is very important. Completely in water ataupun with water. When it dissolves in water, it completely dissociates in water. That is why it is called strong acid. For example, you have Ha. This is the general chemical formula for acid lah. Okay, kita ada A and then H. H represent the proton that will be dissociated later in water, producing H3O plus and A minus. All of these in aqueous state. Nampak tak arrow dia? Arrow dia satu arah saja. Maksudnya completely dissociate in water. Maksudnya at the beginning you letak contoh this is before dissociation, this is how much it is. Concentration dia tinggi. Tapi after dissociation, nampak tak HA? There's no HA anymore available in the water. Tak ada, habis. So all of HA will be dissociated into H3O plus dengan A minus. Itu maksudnya completely dissociate. Okay, later kita akan tengok weak. Kenapa dia dipanggil weak? Maksudnya ada something yang dekat sini lah yang dia tak, dia akan ada, dia still akan ada value dekat sini. That one is weak. Okay, even arrow dia pun kita pakai one single arrow saja. For example, HCl. HCl is a strong acid. Kena hafal. Okay, same goes to strong base. Kenapa kita define as strong base? Because they dissociate completely in water. Okay, so this is how it is. Okay, for example, we have sodium hydroxide. It will be produced, it will dissociate to produce sodium plus and OH minus. Okay, again, kita boleh represent by using this graph. Okay, alright, so to make it easier for you later on, I would highly suggest you to memorize all of this strong acid. Strong base is not much of a problem because you ingat group 1, group 2, hydroxide and oxide, dia strong base. Strong acid. Sebab kita akan ada banyak sangat acid nanti. Okay, I would highly advise you to memorize this 1, 2, 3, 4, 5. 5 acid saja. 5 strong acid saja. Okay, so these are all strong acid. HCl, ingat saya suruh hafal HCl, HBr, HI, HNO3, HClO4 per chloric acid, not HCl, not HClO3, not HClO2, and not HClO. It is HClO4, the only one yang strong acid. Okay, so hafal yang this one. So this is weak acid. Dissociate. See the word partially. Just now apa? Completely, guys. This one partially in water. Okay. If we have, if we react acid in water, okay, this is basically the same as strong tadi. Nampak tak arrow dia dekat situ? Okay, this reversible. Dia sebenarnya reversible jangan tak tahu. Okay, it will produce H3O plus and A minus. Okay, like I said yesterday, it produces H plus sebenarnya. Tapi H plus is very unstable, very reactive. It will react with water to produce this hydronium ion. For example, HF. HF is a weak acid. Okay, it will react with water to produce H2 plus and F minus. So this is how it looks like, guys. So before dissociation, we only have HA. Initially, we only have the acid. Tapi after dissociation, the HA still present dalam significant amount. Nampak tak H3O plus? Only a small amount of H3O plus and A minus are present. So dia tak fully dissociate. Only a small amount of acid dissociate. Small amount of base dissociate. Okay? Alright, same goes to base. Sama je kat atas ni. It's just that dia dissociate partially, guys. NH3 is a weak base. Okay, in water, it will produce NH4+. Remember, this is base. Base maksudnya dia proton acceptor. So, dia akan accept proton from H+. Okay, producing NH4+. And then dia base. Bila base, you must produce OH-. That is characteristic of base. Kena pandai tulis equation. Okay, ini kena betul, this one kena betul. Macam mana tips dia? You tahu you nak buat untuk base kan? You mesti produce OH- lah. You tahu you, katakanlah you kena buat equation for acid. So you mesti tahu you kena produce H2O+. Faham? Jangan mengarut-ngarut tulis. Mesti balance. It must be balanced. Okay, and then ni it's not a problem. F- kan dia jadi. This one nampak tak? Acid, dia anion. Tapi untuk base, it will be cation. Because why? Kenapa? Sebab sini OH is already minus. This one is plus. So this one should be anion. So this is anion. Then this here should be cation. Okay? Alright. So that is all. Habis dah masuk. Okay? Alright. So the remaining will be covered next week. Okay, so ada soalan ke related to strong acid and strong base? Okay, if there is no question, I think that is all, okay, for today's lecture. So thank you everyone for your attention and cooperation, okay, and Assalamualaikum. Bye-bye.